In this lecture, I am going to discuss about the unit conversion, especially in the AC circuits. So this unit conversion is based upon the AC circuits. What are the possible units we are using and changing in the AC circuits? In the AC circuits, four things are very important, and it is very basic thing. The number one is AC supply. So this AC supply, maybe this may be the voltage or this may be the current. This is one basic thing here, and there is a electrical component, that is the resistor R, and the third one is the capacitor. Capacitor is C, and the fourth one is the inductor. The inductor is L. So these are the very basic parameter in the AC circuits. So these are the very basic things when we study about the AC circuits, and it has its own SI unit, and the other units are the practical units which we use generally when we define the circuits. But always for the calculation we have to take only the SI unit or the standard units, not the practical units. So here I am going to discuss one by one about the SI unit. If the SI unit is not given, so how to change the units to the SI units, and what are the common units we are using for the AC supply, for the resistor, for the capacitor, and for the inductor. So what are the units we use? So these are the units generally we use. So this is 1 nano, and this 1 nano is equal to 10 to the power minus 9, and there is a 1 micro, and this is equal to 10 to the power minus 6, and this is 1 milli, and this is equal to 10 to the power minus 3, and this is 1 kilo, and this is equal to 10 to the power plus 3. So this is the big number, and this is 1 mega. So 1 mega is equal to 10 to the power 6, and this is 1 giga, and this is equal to 10 to the power 9. So these are the possible units we use for the unit conversion. And there is a one formula how to change the unit to the number and number to the unit. So here I take one example. If this is 1 micro, and the 1 micro is 10 to the power minus 6. So this is the value for the micro. If you are changing this micro to number, so it means you have to multiply, and already if you have the number and you are changing to micro, so in that way you have to divide. So this is a rule we use. So like for the AC supply, the first one is the AC supply. So AC supply means the voltage and the current. Suppose if I say the voltage of the AC supply is, this is 20 microvolt. So this 20 microvolt. So here the SI unit for the voltage is volt. So this voltage is the SI unit. So you have to change in SI unit. You have to change this micro to its number. Now this this micro you have to change. It means you are moving from micro to number. So you have to change like this. This is 20 and this micro to number. So it is, this is if you are going from micro to number, so you have to multiply this. So this is 20 into 10 to the power minus 6 and volt. Now this number you have to use in your calculation. And sometimes we can take the value from the graph of the AC voltage. Now suppose if this is the graph of the AC voltage. So here this is the voltage, this is the voltage, but this voltage is in millivolt. It is like this. And here this is the time and this time is in second. Now this is the wave of the AC voltage and this is 0, and here this is plus 10, and here it is plus 10, and here it is plus 5, and this is minus 5, and here this is minus 10. So from this graph, what is the value of the maximum voltage? If the question is like this, so it means you have to find the value of the voltage in the volt, not in any other unit. But here this, you see this unit, the voltage, this is the voltage line, and see the unit here, in which unit the AC voltage is given. So here the AC voltage is given in milli, so this is millivolt. So your answer from this graph, it will come in millivolt. So the maximum voltage from this AC voltage graph, so the maximum voltage means this point, this is the V maximum. So it means this is 10 volt. So here this is the value of the 10 volt, 10 millivolt. So here this 10 number will come. So this is plus 10 and this is millivolt. So this value you cannot use. This is in milli. So you have to change to the volt. Now the same rule you have to use. Like if I take from here, from the unit, so 1 milli, this is 1 milli, and 1 milli is equal to, this is 10 to the power minus 3. So the rule says if you are changing milli to the number like this, if you are changing milli to the number, you have to multiply by this number. And if you already have some number and you want to change that number in the form of the milli, so you have to move like this from here to here, and you have to divide in that case. So this is the division here. Now here we have to change this milli. We have to change this milli. So it means we are following this path. This path means we have to multiply by this number 10 to the power minus 3. So here the answer will be like this. So this is V maximum, and this V maximum is, this is plus, and this is 10, and this is multiplied by 10 to the power minus 3, and the unit will be volt. So in that way you have to change. The same thing is for the current, the AC current. If the AC current is given like this, the current is equal to, this is 2 milliampere. So this 2 milliampere you cannot use. This milli you have to change. So how you can change this milli? So the 1 milli is equal to 10 to the power minus 3. So here you are changing this milli to the number. So if you are moving from here to here, so you have to multiply. If you already have the number, and this number you have, and you are going to change to the milli, so in that case you have to divide. So this is the reverse, but in this case we are changing this milli. So here we will use this multiplication. So in this case we will use the multiplication, and this 1 milli, this I equal to, this is 2 into 10 to the power minus 3 ampere. So in that way you have to change. But sometimes the current may be in ampere, like this. The current is equal to, this is 0.01 ampere, and the question may say you change this current to the milliampere. So you have to change this ampere to the milliampere. So the meaning is in this 1 milli equal to 10 to the power minus 3. So in this relation here you have this number and you are going to milli, like this, you are changing to milli. So in this case you have to divide, not the multiply. So your number is 0.01. This is your number in ampere, and you want to change this number to milliampere. So here you have to divide this, so divide this number by 10 to the power minus 3. So this will be like this. So this is 0.01 when after solving. So this is 10 to the power 3, and after solving this, so this will be 10, and this is 10 milliampere. So the meaning is this current is equal to 0.01 ampere. This is same as 10 milliampere. So sometimes the question may say find the current in the particular unit. So you have to change according to the rule given. So this is the rule. So follow the rule. This rule. Sometimes the current is given in the form of the AC current diagram. The AC current diagram is like this. So here, this is the y-axis, the current axis. So here this is the current, and the current is given in microampere, like this. So this is the unit of the current, and here it is like this. And here the time, this is the time axis, and the time is given in the millisecond. And this is the wave, this is the AC wave, like this. And here this is 0, and here say the value is plus 1, and here the value is, this is 0.5 here, and here the value is, this is minus 0.5, and here the value is minus 1. It is like this. So here the two parameters in this AC current, they are not in standard. So not in standard means, if you see here, this timing is also not in the standard form. It is in millisecond. Actually, if you are getting the value of the time of this AC wave, so it should be second. You have to find the time in seconds. So this is one thing here. And if you are finding the current from this AC current diagram, so here also if you see this unit of the current, this is also not given in the standard unit. So here it is given in micro. So if the question from here, from this AC diagram, if you are finding the maximum current, so to find the maximum current you have to go to the peak point here, and where this line is cutting to the y-axis. So this is the value. So here the current value is this one. So the current is plus 1, but here the unit is microampere. So this is microampere. So you cannot give the answer in microampere, you have to give the answer in ampere. So here you can change this. We know the relation. Here. This 1 micro is equal to, this is 10 to the power minus 6. Now you are changing from here to here, so it means you have to multiply. And if in case you have the number and you are going to change to micro, so in that case you divide. So but here we are changing this micro, so it means we will use the multiplication. So here the answer will be the maximum current in the unit of ampere. This will be like this. So here this is 1 and this is into 10 to the power, it is minus 6, and this is ampere. So this is about the change of the unit of the current. But sometimes on the same AC diagram, because here there is a time axis also, so sometimes the question can say what is the time period of this AC wave. Suppose if I give some number here, this is 5, this is 5 here, and this is 10 here, this is 15 here, and like this way. So here the question may say find the time period. What is the time period of the AC current? So here what you have to do, you have to find the time of the one wave. So from here to here, so this is one wave from this point to this point. So this is from here to here, this is one wave. So this is the time of the from here to here, this is the time of the one wave. So you can take the value, this is from 0 to 10, so it is 10, the number is coming 10, but you have to write the unit of this time, what the unit given on the axis. So here this time is given in the millisecond. So here the time is, this is millisecond, not the second, but this value in millisecond can't be used in any calculation. So you have to change this milli you have to change. So you know the 1 milli is equal to 10 to the power minus 3. So this is 10 multiplied by 10 to the power minus 3, and this is second. So this is the value of the time period. So this is t equal to, and this is 10 to the power after calculation minus 2 and second. So this way you have to find the time period of the AC wave, AC current. So once you have the value of the time period, easily you can find the value of the frequency. Now suppose if you want to find the frequency of the AC current, so this we know the formula, the frequency is this 1 over T. Now in this formula, this T should be always in the unit of second, not in any other unit. So it means already we got the value of the T in second, so we have this number. So now this is equal to, so this is 1 over, and this is 10 to the power, this is minus 2, and this after solving, so this will come, it will come 100, and this is 100 hertz, like this. Now this answer is coming, but sometimes if you have to find this answer in the unit of kilohertz, not in the hertz, like here if you have to find the answer in kilohertz, here the answer is coming in hertz, but sometimes the question will say you have to find the answer in kilohertz. So for the kilohertz you have to write the relation between the kilo and the value. So we know this 1 kilo is equal to, this is 10 to the power 3. Now the rule is, if you are changing, already if you have the kilo and you are changing to kilo, so it means you have to multiply. But if you don't have the kilo, you have some number and you want to change that number in the form of the kilo, so it means you are not moving from this side to that side. It means you have to move from this number, you have to move this number to kilo, so like this way. So here you have to divide, not the multiply. So the meaning is, to change this hertz to the kilohertz, you divide this by 10 to the power 3. So whenever you will divide this 10 to the power 3, so your answer will come, this is 0.1. So in that way, both side you can change, okay, from unit to the number, or if you have the number, you can go back to the required unit, what the question is asking or what is required by the question. If the resistor is given like this, so this is the R and this R is 10 giga ohm, it is like this. So for any circuit you cannot use this value 10 giga ohm for any calculation. So this is R equal to, it is 10 giga ohm, this should be in ohm, not in giga ohm. So we know the relation between the giga and the number, so this 1 giga is equal to 10 to the power 9. So I told you the rule we are using. So if we are moving from this side to that side, we always multiply, and if we have the number and we are going to the unit, the giga, so in that case we divide. So this is the way. So here we have this giga and we want to change this giga, so it means we will use this multiplication. So here our number is, this is 10 and this is multiplied by 10 to the power 9. So this way we use the relation between the giga and the number. And sometimes in the similar way, this R may be used like this. Okay, if we say this is 50, this is mega ohm, like this. So in the same way, we can change the mega to the ohm, and we know the relation between the mega and the ohm is, so the relation is that 1 mega is equal to 10 to the power 6. So now if you have to change this mega to the number, so you have to multiply, and if the number is given and you have to change to mega, so you have to divide. So here this is the ohm, so this mega ohm you have to change to ohm. So here this we will multiply, we are changing this mega to the ohm, so we will multiply here. So our number is 50, so it will be multiplied by 6. So in this way we can change. And suppose if the value of the resistance it is given, this is, if suppose if some small value is given, so this is here, this is 20 and this is milli ohm. So we know milli, the milli is 10 to the power minus 3. So this milli, we know the value of the milli is 10 to the power minus 3, and we want to change the milli. So here this milli you can change to 10 to the power minus 3, and this is ohm. So in this way we can change the units, especially for the resistor. And sometimes you have to go opposite. Opposite means if the value of the R, the value of the R is given, the value of the R is given, this is 5000 ohm, and you have to write this in kilo ohm. So here you are going opposite basically. So here you have to write the relation between the kilo. So this 1 kilo, we know this is 10 to the power 3. Now if you are moving from, if you are changing the kilo to the number, so you have to multiply. If you have already some number and you are changing to kilo, so it means you have to divide. So in our case here, we have this number here, we have this number, and we want to change this number in the kilo. So it means we will divide here, we will opt this division, because we are changing this number to the kilo, we are going to kilo. Now this R is equal to, this is 5000 and this is divided by 10 to the power 3, and after the calculation it will come 5, and this is kilo ohm. So the same thing we can do for mega ohm and the giga ohm, anything for any unit we can go reverse. For the capacitor, if the value of the capacitor is given, this is 25 nano, or this is 2.5, this is 2.5 in nanofarad. So the value of this 2.5 nanofarad you cannot use for any calculation. So here you have to, here the value of the C is, this is 2.5 nanofarad. So you have, the unit is, this is the unit farad. This is the unit farad. So the value should be in farad, not in the nanofarad. So here your answer should be in farad. So we know the relation for the nano, that 1 nano is equal to 10 to the power minus 9, and the same relation, the same method to change. So if you have the nano and you are changing to the number, so you have to multiply, and if you have the number and you are going to nano, so you have to divide. So this rule we use. Now here we already have this nano, and we want to change the nano to the number. So this operator we will, multiplication we will use. So here this C is equal to 2.5 into 10 to the power minus 9, and this is farad. So this way we can change the unit of the capacitor, 2.5 nanofarad, it is equal to 2.5 into 10 to the power minus 9 farad. So this way we can change. And sometimes the value of the capacitor may be like this. If the capacitor value is 41 into 10 to the power minus 5, and this is farad. Sometimes the question will say find the value of the capacitor in microfarad. So this is coming in farad. So you have to change this to the microfarad. So here it is a reverse. So for this case we know this is 1 micro, and this 1 micro is 10 to the power minus 6, and if you are changing from here to here, from micro to numbers, you have to multiply. If you have the number already and you are going to change to micro, so you have to divide. So this way, and here already we have this number, and we want to change to the micro. So we will follow this operator, the division. So here this C is equal to 41 into 10 to the power minus 5. So divide this value by 10 to the power, and this is minus 6. So after the calculation, this will come 410 microfarad. So this is a reverse conversion. And after, there is another component, and that component is the inductor. So what are the possible units we use for the inductor? So this is here it is an inductor, and if we say the value of the inductor is, this is 18 millihenry. Henry is the unit for the inductor. So the unit is, this is the unit. So here the unit is the unit here, the unit is Henry. This is the unit. So the value should be in this Henry. This H, it should be in the H. So for this case, this is Millie. So here the value of the L, it is given, this is 18 millihenry, and we know the value of so here the value of the L is 18 millihenry, and we know the relation for the milli. So this is milli, 1 milli is equal to 10 to the power minus 3. Now we have the method, if we are changing the milli to the number, so this is multiplication, and if you have the number already and you want to change the number in the form of milli, so go for the division. Now here this unit millihenry, you should change to Henry. So here the value of the L is 18. So this is multiplied by 10 to the power minus 3. So this is Henry here, like this way. Now sometimes it may be reverse. So the reverse, if we say the value of the L, is it is 1800 Henry. So how much it should be in microhenry? So you have to change this Henry in the microhenry. So how you have to do this? So first you write the relation between the micro and the number. So the micro stands for 10 to the power minus 6. Now if you are moving from here to here, so you multiply, and if you have the number and you are changing to micro, so this you have to divide. Now here you have the number. Now this is your number, and you want to change this number in the form of this micro. So this is the number here. If you want to change this number to the micro, so you have to use this division. So now this is L equal to, this is 1800. So divide by 10 to the power, it is minus 6. You have to divide. So your answer will be 1800 into 10 to the power 6, and this is Henry. So the unit, the SI unit of L, the SI unit of L is Henry, or in the short form it is H. So same way for the capacitor, the unit for the capacitor, the SI unit of the capacitor is farad. This is farad, in the short form F. So for every calculation, this should be in farad here, and this L should be in Henry, not in millihenry, not in kilohenry, not in microhenry, not in nanohenry. It should be in Henry. So you have to change anyways. And the same thing is for the capacitor. If the capacitor is given in microfarad, nanofarad, millifarad, anything, you have to change all these things to the farad only.